Hello everyone, my name is FATIN SHAHABUDDIN. I am from 2023. First of all, I want to talk about the introduction for our assignments. This research based on Everett Rogers, which is Diffusion of Innovation Theory, which examines how innovation speed within a population or social system. This study uses regression analysis to explore the relationship between dependent and independent variables, focusing on three main independent variables, which is the first one, complexity, relative advantage, and compatibility. Additionally, the study incorporates four demographic variables. Data collection will involve a questionnaire with 60 respondents. The analysis process includes descriptive statistics, normality test, person correlation, Cronbach alpha, regression analysis, multicollinearity check, and interpreted results. The study aims to identify factors influencing innovation addiction, offering insights for business to promote the spread of innovations. First of all, I want to talk about the item total statistic for independent variables, relative advantage. As you can see the table, first of all, scale reliability. The overall scale is a moderately reliable. RA1, which is removing RA1 slightly lowers the average score but retains strong reliability. The next one is RA3, which is a weakest correlation with the scale 0.4969, removing it increased reliability. And the suggested co-enigma with items. Standard deviation, which is at 2.92, indicating a moderate spread of participant scores. The conclusion is each item contribute differently. RA3 may require a revision or removal to improve its case reliability. The item for the statistic for independent variable compatibility. As you can see the table, first of all, the scale reliability, high reliability with a Cronbach alpha ranging from 0.797 to 0.839. Item correlation is CY4, the strongest correlation with the total scale 0.751, and CY3, which is the weakest but still good correlation, which is 0.667. Standard deviation with this independent variable is 2.92, indicating moderate variation in responses. Conclusion for this independent variable, this scale is variable and removing any item does not significantly impact it, and it is consistency. Then, the item of the statistic for independent variables complexity. The set reliability is the scale is moderately reliable overall. Item contribution CS1 and CS3 are somewhat aligned with the total score. CS2 has the weakest correlation, but removing it only slightly lowers reliability. CS4 has a decent correlation, removing it causes a bigger drop in consistency. Average score is 8.8833 with moderate variation in responses. The conclusion is the scale is reliable, but some items like CS2 may require future evaluation to enhance consistency. And the item of the statistic for dependent variable, which is addition decision. Set reliability is highly reliable with each item contributing well to consistency. Item contribution is 84, the strongest condition to the total score, but it is removable still keeps the scale reliable. 81, 82, and 83 good correlation with minimal drop in reliability were removed. Average score is 7.35 with moderate variation in responses. As you can see, the standard deviation for dependent variable is 2.77290. The conclusion for this dependent variable is the scale is dependable, with each item helping maintain overall consistency. Then descriptive statistic for overall. Average score is AD, the lowest average, which is 1.8375, and C as the highest average, which is 2.2208. Then the standard deviation range from 2.69323 to 0.73371, indicating similar spread in responses across one variable. Sample size consistent at 60 participants for each variable. The scores are relatively close to each other, with consistent variation across the variable.
For mean and maximum predicted score range from 1.25 to 3.60 with an average of 1.84. For residuals, range from negative 1.42 to 1.40 with an average of 0, indicating no systematic or over underestimation. For standardized predicted values, most prediction fall within a typical range, showing reasonable variation. For standardized residuals, most difference between actual and predicted value are within a reasonable range. For model accuracy, overall the model's prediction are not accurate with no extreme error or outliers. For t-test average score, males and females have a very similar average score for 81, 82, 83, and 84. The gender differences, males generally have slightly higher average score across all items. For the score variability, females, more variation in score indicating answer are more spread out, while for males, more consistent score suggesting less variation in responses. The conclusion is while average score for both gender are similar, females exhibit more variability in their answer compared to male. For normality test histogram overview, the blue bars represent the frequency distribution of standardized residuals of dependent variable AD. For normal distribution comparison, the black curve shows the ideal normal distribution for comparison, while for mean of residuals, the mean of the residual is nearly 0, 3.40 E60, indicating the data is centered around the mean. For standard deviation, the standard deviation of the residual is 0.974, indicating the spread of the data. Alignment with normal curve, the histogram aligns fairly well with the normal curve, suggesting that the residuals are approximately normally distributed. For importance, this normality indicates the assumption of normality is met, which is crucial for many statistical analyses, including regression. For dependent variable purpose, the plot check if the residual of a regression model follow a normal distribution. The axis vertical axis expected cumulative probability based on a normal distribution. For horizontal axis, observe cumulative probability. The ideal line, the black diagonal line, represents the scenario where residual perfectly follow a normal distribution. For the interpretation, most points lie close to the diagonal line, suggesting residual are approximately normally distributed. For minor deviation at the tail suggests slight departure from normality. The important is the plot is commonly used to validate the assumption of linear regression. The next is for correlation variable analyze AD, RA, CY, and CS positive relationship. All variables show positive relationship, meaning as one variable increases, the other tend to increases as well. The strong correlation RA and CY, a strong positive correlation of 0.851. Meanwhile, for AD and CY, moderate to strong correlation of 0.613. The weakest correlation is AD and CS with a correlation of 0.270, but still statistically significant. Statistical significance, all p-value are less than 0.05, indicating the relationship are statistically meaningful and not due to chance. The sample size, the analysis is based on 60 data points for each variable. For item total statistic for relative advantage, effect of item removal, the table show how removing each item RA1, RA2, RA3, and RA4 affect the average score and spread of the scale. RA1 best correlation with the overall scale 0.651, indicating it fits well with the others. RA3 lowest correlation with the overall scale 0.469, suggesting it might not fit well. Impact of removing RA3 slightly increase the overall reliability of the scale, implying better consistency without it. The purpose is the table help assess the importance of each item for maintaining the scale consistency and reliability. The next one is item total statistic for independent variable compatibility. The effect of item removal, the table show how removing each item CY1, CY2, CY3, CY4 impact the average score and consistency of scale. CY2 best relationship with the overall scale with a corrected correlation of 0.711, indicating it fits well. CY4 highest corrected correlation of 0.751, but removing it slightly lower the scale reliability. For CY3 lower overall reliability, suggesting it might not fit well with the other item. The purpose is the table help identify which item are most consistent with the scale and how the removal affect the overall reliability.
The table show how each item CS1, CS2, CS3, and CS4 affect the scale we remove. For example, if we remove C1, the average score drops to 6.7500. CS4, the best fit with the scale, we have strong correlation of 0.627, meaning the highlights will be the other items. But removing CS4 lowers the overall reliability of the scale. CS2 has the lowest correlation of 0.469, so it doesn't fit as well with the others. But removing CS2 also reduces the scale reliability. In summary, CS4 is more consistent with the scale, while CS2 doesn't fit well and removing it lowers reliability. The table show how each item AD1, AD2, AD3, and AD4 impacts the scale we remove. For example, if we remove AD1, the average score becomes 5.3833. AD4 fit the best with the scale with the highest correlation, 0.843. However, removing AD slightly lowers the scale reliability. For AD1 has a moderate fit and removing it still keeps reliability high at 0.898. AD3 and AD3 have a good correlation, but removing this slightly reduce the overall consistency of the scale. In summary, AD4 fit the best, but removing AD1 has the least impact of reliability. The table shows the result of relation analysis with the three independent variables, which is relative advantage of compatibility and complexity, and the effect of the independent variable adaptation and decision. For RA has a small positive effect as a ADB equal to 0.0061, but it's not statistically significant. So significant 0.753, meaning it's not important predicted to AD. So for CY has a strong positive effect as AD B equal to 0.533 and significant equal to 0.007, making it most important predicted in the model. But for CS has a very small negative effect on AD B equal to negative 0.008, but it also not significant. So significant equal to 0.941, so it doesn't much important. The correlative statistics show the major issue although RA and CY has modulated high value, which is negative 3.750 and 3.668. In summary, CY is the key factor influencing AD, while RA and CS have minimal or not significant impact. For R square, the table show how well the independent variable CX, CY, and RA predict the dependent variable AD. The R value of 0.614 indicated the moderated relationship between the variables, while the R square value 0.377 means that above 37.7 in the variation in AD can be explained by CX, CY, and RA. The adjusted R square of 0.343 is slightly adjusted for the number of variables in the model. The standard error estimate is 0.561181, showing that prediction are fairly close to actual values. The problem was a value of 1.787, suggests there are no significant issue with the auto-correction, meaning the error the prediction are not systematically related. In simple terms, the model expects a little over 1/3 the variation in AD and provide reliable prediction. The table shows how the independent variable RA, CY, and CS are related to each other, which help us to check multipolarity when the predicted are too close related. The correlation index value is 50.038, which is below the critical level of 30, so there are no major issue with the multipolarity. The various proportion show that RA and CY are highly related, which is 0.91 and 0.90 in the mission form, so indicating a strong correlation between them. Overall, there is no some correlation between the variables, but it's not strong enough to cause addition and recent results show that compatibility significantly influenced the adoption decision is 0.007, making the most important factor. However, relative advantage 0.753 and complexity is 0.941 have a significant impact, meaning that there are no play major role in adoption in this case. In summary, compatibility is the key factor driving innovation adoption, where the other factors are less relevant.